All right, so in this video, they want us to calculate the thickness of the runway. And so I highlighted a few things here. One thing we would remember here is that T doesn't stand for time. T actually stands for thickness. The W is equal to the weight of plane. Now, they asked us to do graphically, numerically. I'm just going to solve it numerically by using algebra like in the previous lessons because it's faster. I did leave the pictures for the graphically so we can match our answers up here in a moment as we do this. I wanted to point out they'll recommend on some of the homework problems a scale to do the window by. So this first one is the X part of the window. So if you press window and go through and say, all right, the X min is 0, the X max is 10, and the X scale is 1. And then the second set is the Y values. So the Y min is 0, the Y max is 200. Now we know it's hard to put 200 lines on the going vertically, so we're going to say the Y scale. Let's go by 50s. That way we actually see it a little bit easier. And that's what we see here. So they show where the intersection is. They show us in the table that X is approximately 8 is where that occurs. And so let's go over and solve it algebraically. So they tell it's a 130,000 pound plane. Here's the thing. They tell us that it's set up to be thousands of pounds, which means that 18.29, that's already got it in thousands of pounds. So as we go to set this up, we're really going to put 130 is what we're going to do here and say it's 130,000. Because technically on their equation, it is basically with thousands after it is what it has. So once we put T in there, then we get an answer, and it's thousands, so we put 3 zeros on it. So that is equal to 18.29 e to the 0.246 t. So we're going to do inverse operations and start solving for the e to the power. So we're going to divide both sides by 18.29. Again, I would leave it like that. Don't divide it out. Leave it as a fraction. So 130 over 18.29 equals e to the 0.246t. Then we have to remember that ln and e are inverses from our previous lesson. We can also think of this as log base e, and that's what ln is, the natural log. So we're going to take the ln of both sides. And when we do that, what we're able to do, based on our previous lesson, is we can cross off the ln and the e. They cancel each other. They need to negate each other. So we have the ln of our fraction over 18, there we go, equal to 0.246t. Technically, I divide both sides by 2.46 to isolate my t. And again, I'm going to be careful. I'm not going to type this in the calculator in one fell swoop. You could. I just think it gets a little bit complicated. So what I'm going to do is I'm going to simplify the top, leave that decimal in the calculator, and then I'm going to divide it by 0.246. So let's split our screen over here. And there's my calculator. So ln alpha y equals to get a fraction. On top, I want 130. On the bottom, I want 18.29. Arrow to the side. Let's close it and hit enter. I'm going to take that decimal and divide it by 0.246 and hit enter. And I get that t is approximately 7.9723, and that's in inches. So it needs to be about approximately 8 inches. Now that matches up with our picture. Remember, they went by scale of 1 here, and we can tell that it's 8, it's a little bit bigger than 130. So it happened a little bit before that, so somewhere between 7 and 8. And remember, our answer was 7.97, which makes sense, for what's happening. So, so again, I think the algebraic way is a heck of a lot faster than the graphic and changing the scales.